Section B then. Okay, so most of you got all this right, but let's go over it anyway, and this will go on the video for anyone else who can catch up later. Certainly Henry would want to look at this. So this is angles on a straight line. Subtract these two numbers for 180, 69 degrees for H. Here angles is a point adding up to 360. Add up that little lot, subtract from 360, you get 67. The last one is still angles at a point, recognising of course that little part there is, just do that little part there is 90, so subtract 82, 90 and 73 from 360, you get 115. You can stop me at any time if you've got a question. This is a lesson, it's a go over lesson, and I expect to be taking questions. So 10A then, the sum of the interior angles of a regular hexagon. Well, 6 sides will give us 4 little triangles if you don't overlap anything. So 4 lots of 180 will give us 6 angles totaling 720 degrees. 2 marks, one for the working, one for the 720. I'm not sure if I'd give 2 marks for just that anymore. I don't think I would. Find the interior angle of a regular octagon. Okay, the interior angle. But if I've got 8 sides, I'm going to create 6 triangles on the inside. So I'd like to see 6 times 180 makes 1080. Then of course you can divide that by 8 to get the interior angle of each one. Will be 135. Get a slight upgrade coming up. A number of ways of working out question 10 part C. I did it the traditional way. I'll show you 2 ways of doing it. Here's the long way, which we would have done in class, and for many of you I showed you the second way as well. I had it projected on the Mimeo. So part C then, if I've got 15 sides, I will get, without overlap, 13 beautiful triangles drawn from one vertex to all the other vertices, all the other 14 vertices. You'll be able to count 13 triangles, but don't even bother trying to draw it. There's no point in that. So 13 lots of 180 comes to that number. If I want to find out one of the interior angles, I must divide that by 15. So the interior angle of a regular 15-sided shape, which probably has a name, is 156 degrees. To go exterior, you take this away from 180, and that will give you excuse me, 24 degrees. Now, 3 marks for that because there's 3 steps. However, if you use this method, the fact that if you divide 360 by the number of sides straight away, you will get one exterior angle of 24. So if you can understand this rule and are happy to use it, I'll give you 3 marks for that. But many of you went down this route, which is good. This is fine because it's the quicker GCSE way of doing it. And I know there was an exercise, I can't remember what page it was, obviously, but where this was, you could have practiced this rule. So that's question 10. Question 11, I didn't require working for it. There wasn't a lot of space to do working anyway. So the implication was don't beat yourself up about it. So, but I need to talk you through it because not everyone got 7 out of 7. Let's see what I've got. Let me talk you through it. I suppose I should do A first, but I don't see why I should. But okay, I'll do it. Let's generally do it in the order in which it says. Well, A is 50 degrees because 50 given is alternate to the A in that position. So A is going to be 50 degrees because it's an alternate angle to the 50 given. Who says? Well, these lines are parallel, which means you can justify this being an alternate angle. Hence A is 50. Then we're going to go on to B. So I've got 113 outside as an exterior angle to that part of the triangle. If that's 113, angles on a straight line add up to 180. So subtract 113 from 180, you'll get 67. So I've got A and I've got B. Well, I'm directed to do C next. If I know B is 67, then C must also be 67. As you can see, that's an alternate angle. So C is also 67 for that reason. After C comes D. Well, they've given me a 50. I've just worked out C is 67, and this is a straight line, because if it wasn't, it's got no right having a little arrow on it to show that it is a straight line running parallel with that, and none of this maths will work at all. So you have to assume and know that it's a straight line. Well, this angle's on a straight line yet again, 180 degrees. Subtract the 50, subtract the 67, and you'll get 63. So that triangle is now taken care of and all its answers. After D comes E. Oh, there it is. Okay, well this is the way I did E. If that's 50 degrees there, this must also be 50 for F. I'll do F first because they're vertically opposite angles. Look, got two straight lines crossing over each other, and vertically opposite angles are identical. Hence, F is 50. If F is 50, and I continue on to make a straight line with these two angles on a straight line make 180, hence E must be 130. I'm guessing there must be another way of making E 130, and I've just seen it. I don't know if you can see this, but 67 plus 63 is vertically opposite to E, which I think is the harder way to do it. 67 and 63 is 140 plus 10, so 120 plus 10, 130. See, maths always works. That's why I actually like it. Hated it at school, couldn't do it. Love it now though, love it. Which is why I like teaching it, which is why I'm probably quite good at it. So there we go. We've got 7 angles a mark each. Hope you're taking notes. If not, obviously get the video and don't leave yourself without essential knowledge for year 10 and 11. This is where we're going. Question 12. I'll project it in one lot. This is the only part of the y equals mx plus c teaching which is strictly for year 9s. In year 8 you've never had to rearrange anything, but I made a big issue of it. When you all reach this particular part in your studies, I said, now this is the only year 9 bit. If you can rearrange this and understand that y equals mx plus c, then you can find the gradients of the rearranged form. See, taking this here, I've got 2y, half of an x plus 2y equals 5. Please don't tell me the gradient is half, because it's the number in front of the x, because I don't have one y, I've got 2 y's. So let's just rearrange it. So 2y equals 5, take away 1/2 of an x. We're on our way now. Now, we don't want 2y, we want single y. So divide everything by 2. Half of 5 is 2.5. So my intercept is 0, 2.5, or just 2.5. And my gradient, well, 1/2 of 1/2 is 1/4. So it's -1/4. So it's 3 marks. 1 for successfully rearranging, and 1 for the gradient, and 1 for the intercept. So it's quite generous. Okay, for part B, we have 2x minus half of y is 5. Be very careful. You do not want half of y. You want a proper positive half y. So the first thing I did was to take my minus y over and plus it. I mean, I'm going to just do it anyway. So if this was me, I'm going to say 2x is 5 plus half of y. I just did that. And then I said, wrote it around the right way. Is that correct? Yeah, then I said half of y equals, let's get rid of the 5 now to get the form of y equals. That's going to be 2x take away 5. And that's what that step is right there. And then you divide by 1/2. Or if you don't like dividing by 1/2, just multiply everything by 2 to double up. If you got a half y and you multiply by 2, you're going to get that. Yeah, this bit just here. So you get 1 whole y equals 4x is minus 10. Yeah, a bit tricky that. But I have to give you an upgrade from question A, otherwise no point testing the same thing twice in the same way. Quite tricky there. It's a difficult rearranger as well, but it's grade 9 and it's working at grade 5 for sure. So y equals 4x take away 10, the gradient is 4 because of that, and the intercept is 0 minus 10, or just minus 10 because of that little bit there. All right. Question 13. I'm not doing this because it's year 10, high level, grade 7. Obviously some of you either studied it genuinely and revised it, or you genuinely cheated and thought, perpendicular lines, how do I do that? Whichever way, I don't know what you did, only you know. So I'm not going to go over it. Question 13. was generally well done, a basic locus question, still operating at grade 5 GCSE, because loci is grade 5. So you want to stay 3 centimetres away from that line drawn, so you can pick up your ruler and go 3, 3 away from the line. You can open up your compass with a radius of 3 centimetres, stab it right there and draw a semicircular arc and try and do the best join you can. Then stab it right there. As you can see, I've got a little bit of an overhang there. It doesn't matter. The intention is correct, and I gave myself 3 marks. I'll do the same for you. So you stab it right there with your radius on 3 centimetres. Just draw around. If you draw around, like say, too much, then just rub it out. Okay, because you don't want to be too sloppy with these. But a little bit of an overhang, like that little bit that's overhanging a bit, doesn't matter. There's 3 marks. This is a 5-mark question. I'll shrink it down just a little bit. Okay, I hope you can see that. So I have got 2 walls, AB and AC, and I want to put up a mobile phone mast for my 5G network, and it must be an equal distance from the wall AB and the wall AC, and it must be between 40 meters and 70 meters from A. And because this is a proper scale diagram, they want you to use 1 centimeter to represent 10 meters. So you're doing a plan of where you're going to put the phone mast potentially. So the word equidistant means same distance from or the same distance between. And since you're given 2 walls and you've got a blatant angle looking at you, you better just bisect this line skillfully. And that's 3 marks alone. So there's no guesswork as to where it goes. Neither are you supposed to pick up a ruler and say, I think that's roughly the middle. You've got to construct it. If you don't construct it, you're not using your loci skills. So this is physically what I did. Now that we've seen the question, let's just make it a little bit bigger. Obviously not that big. A teeny bit bigger. That's too small. Then I can get close to it and maybe annotate a bit more. Oh, that'll do. How to bisect a line, very simple. There's a lot going on here. You put your compass point right there and you open it out ever so slightly and you swish across like that. That makes 2 what I call stabbing points, there and there. 2 stabbing points, yeah, can you see that? Kind of. Hard to draw. Is that all right? So where the 2 little tiny cuts pass through the 2 walls, AB and AC, you now got points to stab. So then I put my compass needle there, open it up a little bit more to make sure the arcs going forward do actually overlap. And I went swish for that one. I stabbed it there. I went swish for that one. As you can see, this will be a whole circle if I carried on swishing. So I've got 2 points which serve as markers for me to use my compass needle. And I've got 2 arcs that overlap. Once I've got that point there, I'll pick up my ruler, go straight the way through, and don't stop because you don't know where the question's going to go. That's 3 marks. Now there's another twist to it. This mast has got to be between 40 and 70 meters. Now you're forgiven if you picked up your ruler and went little mark, yeah, that's where the 40 is, little mark, that's where the 70 is. Still a bit sloppy for grade 5 loci questions. Like I taught you in class, you pick up your compass, you open it out to a radius of 5 meters. So 4 meters, 4 centimeters because it's 40 meters. I get that. So opening out to 4 centimeters and just swish it through. And I'll be looking for a nice little cut around there, but show me where the cut came from. Otherwise it could be just a freehand little scribble with the ruler. Now make it crisp. And also 70 meters from that point, which is 7 centimeters. Again, open out your compass and just draw around. So now I've got myself 4 marks. Yeah, 1, 2, 3, 4. Now where's the mast going to go? Somewhere on this bisector, but must be between these 2 arcs. So anywhere between there and there. Now I don't mind how you indicate it. You can highlight that in super thick. You can say, oh, in there somewhere. I just did 2 arrows to show from there to there. I could put the mast there, then I get the best coverage. 5 marks. And that's all the possible positions. Question 15. I've got a boat and I'm sailing from the dock at D. So I'm going in this direction, and it's a scale diagram, 1 centimetres, 2 kilometres. First thing, work out the actual distance of the boat from the dock. All you have to do is to measure this and times it by 2. Well, when I did it, okay, can you pause that sound? I measured it as 8.5 centimetres, so double it up to respect the scale and you'll get 17. I don't really mind what you got. I would like to have seen something like that to show that you're doubling up and giving due consideration to the scale. 2 marks for that. Then it says, measure the bearing of the boat from the dock. Measure the bearing of B from D. They want you to measure that one right there, yeah? And I made it on my one 114, approx. You might make it a little bit more, a little bit less. But if yours was too wild, you lost that mark for not being careful enough. Now, admittedly, it's very hard for me to judge that when you're sending me wonky pictures to the side and it's not clear. I had to make the best judgment I can, and I did have my protractor here, which I used to actually measure it. Yes, it's still there. So yeah, I actually physically put my protractor up against your picture and measured it. You had to be close to 114, but not wildly out. Okay, so we're up to 4 marks. Next one, we've got a boat, now we've got a yacht. A yacht, which I've called Y, is found to be 8 kilometers from the boat on a bearing of 050 degrees. So we're looking for something 4 centimeters on our scale away from boat B at a bearing of 50 degrees relative to the north line. So you've got 1 mark for the 4 centimeters and 1 mark for the 50 degrees. I was actually looking for a little dot about there, because if you got that right, I knew the 4 centimeters wouldn't actually reach that, because I know with a standard protractor they've got a radius of 5 centimeters. So I don't know if you can tell, but there's a distance of about 1 centimeter there. Certainly, if this page was to scale, that would be like a centimeter. So that little, I was looking for a little dot to show that your 50 was correct. You would have got 1 mark for that. And if your line therefore followed that dot and was shorter than that dot, I trusted that it was actually 4 centimeters. You got that mark as well. Just to have a dot out there somewhere, couldn't judge it. You know, I need to see a line and the dot, not just the dot, to convince me it was correct. Not difficult. Last little bit, again, not difficult. Some you got it completely correct. So the bearing of a ship from a lighthouse, so SL, again, straight out of the Year 9 book, this kind of standard, is 58 degrees, 050 degrees. So we've got to look at the language, the bearing of a ship from. So I'm starting from L, and mine isn't a scale diagram. It looks like 58 degrees. No, it looks a bit like 58. I didn't actually draw 58. It doesn't matter. It's a diagram as a rough sketch to help me. What is the bearing of the lighthouse from the ship? So I drew myself a nice long line up to about there. Then I said, well, let's make the ship about there, shall we? And this is what I did. If that's 58 degrees, then that part's going to be 58 degrees also, because it is a corresponding angle. And the bearing of the lighthouse from the ship is that part right there. In other words, 58 plus 180 would give me the 238. And there's other ways of doing it. I could have done this. I could have said, oh, these two angles, Isabella, they're allied angles. So if I add them both together, it should come to 180. And so what's that going to be? 112, 122, 122. So 122 degrees is that. Then what could I have done? Does that actually help me a great deal? Yeah, I suppose I take 360, then I take away my 122, and that should give me 238. Yeah, 0 and 2 gives me an 8. Yeah, that works. However your brain sees it, doesn't matter. 2 marks available for that. I don't mind how you did it, but a picture definitely helps you to get your bearings right, literally. Pardon the pun, wasn't planned, never is. Nothing I do is planned other than drive to school. I plan that. The rest, hey, whatever. So that's that. I want to stop the vid